In sixth grade, you did some work with inequalities, but we're going to reintroduce inequalities today in seventh grade, Unit 6, Lesson 13. So let's go ahead and work with some inequalities. Our goals today, I understand what it means for a number to make an inequality true. I can explain these symbols, we call those less than or equal to and greater than or equal to, and also I can represent an inequality on a number line. So to the left, you're going to see x is greater than 2. If we show that on the graph, you can see how I've shaded in all the numbers that are greater than 2. Here, this inequality symbol shows you that x is greater than or equal to 2. If we look at the graph below, you're going to notice it's very, very similar to x is greater than 2 in the previous example. But here there's a subtle difference. The dot that's around the 2 is shaded in because 2 is equal to 2. All right? This one means x is less than 2. So here all the numbers to the left of 2 are shaded, but notice that 2 itself, it's not shaded. And this is x is less than or equal to 2. So this time again, all the numbers to the left are shaded, but 2 itself is also shaded. So when you're graphing inequalities like this x is less than or equal to 2, I want you to note that the numbers that make the inequality true, those are shaded. And you're always going to make a circle at the boundary point. You're going to shade it in only if it makes the inequality true. All right, substituting a value in for x and considering whether the inequality is true is the most direct way to check if the value is a solution. So let's do an example. I have the inequality 5 minus x is greater than 2. I want you to determine if each of the following are solutions to that inequality. So go ahead and try that on your own and then check back with me and see how you did. All right, x equals 1. You would substitute 5 minus 1. You would get 4, and that is greater than 2. So yes, that's a solution. For the second one, you would do 5 minus 4, but that's 1. 1 is not greater than 2, so 4 is not a solution to this inequality. How about 5 minus negative 5? Oh yeah, remember that's the same thing as 5 plus 5. We get 10. 10 is greater than 2, so negative 5 is a solution to this inequality. And if we plug in 3, 5 minus 3, that equals 2. 2 is not greater than 2, so no, that's not a solution to this inequality. All right, I just want you to think about those 3 goals. What does it mean for a number to make an inequality true? Can you explain these symbols when they have the little bar underneath them? That also could be an equal sign, less than or equal to or greater than or equal to. And then can you represent an inequality on a number line?